Hi, in this demonstration, we will look at the analysis of the Microsoft Office document containing the malicious macros. So this is the document that we'll be analyzing. So once I open this document, you see that it gives a security warning saying that macros have been disabled. Do you want to enable the content? So this indicates that there is a macro that is embedded inside the Word document. Now, how do we look at the macro code? So there are different ways of looking at the macro code. So if you're on Microsoft Windows, one method is by pressing Alt F11, that will bring up the Visual Basic Editor and it will show you the macro code associated with this document. This is the macro code that is associated with this document. So this is one method of looking at the macro code. But there are other methods of looking at the macro code. So there are tools that allows you to extract the macro code from the document file. So the one such tool is OLE tools, which allows you to investigate the malicious Office document files. But one of the scripts that can be used to extract the macro code from the malicious document is the OLE VBA. So what I'll do is I'll copy this document file into the same folder and let's extract the macro from that document. I'm going to redirect the output into a text file, and now let's look at the text file, see what we can find. As you can see, the OLE VBA was able to extract the macro code that we saw in the Visual Basic Editor. Apart from that, OLE VBA also gives you some very interesting information, some of the characteristics of the macro. It tells you that there are some auto-executable functions. We'll talk about auto-executable functions in some time. And also it tells you there are some suspicious keywords that are normally associated with the malicious activity. And also it tells you that there are some indicators of compromise, like there are reference to a URL and an executable file. This can be useful when you are analyzing the malicious Office documents. Okay, so these are some of the methods of extracting the macro. Now that you have extracted the macro, you can look at the code and try to figure out what is the functionality of this macro. But the problem is most of the time these macros are obfuscated, which means it's very hard to read the code and understand the functionality of the malware. For example, here, let me bring up the Visual Basic Editor. This is the same code as the Visual Basic Editor. So you see that the function names doesn't make any sense here, and the variable names doesn't make any sense. But sometimes when you're looking at the code, it is possible that you might find some very interesting references. Like for example, here there is a reference to an URL and also reference to an executable, indicating that probably this macro code is going to download an executable from this particular URL, right? So, but again, not always there will be references to strings like this. Most of the time, the code is heavily obfuscated, which means we need a different way of analyzing this macro. So the best way to analyze the macro is to debug the macro. Okay, so you can debug the macro using the Visual Basic Editor itself. But before you debug, I would like to explain few things about some. I'd like to explain some of the subroutines that are really important while analyzing the macros. So if you are analyzing the Word document, look for these subroutines. Because the reason why you probably want to look for these subroutines is because whenever a Word document is opened, these subroutines get executed automatically. This is like the main function in the C program, right? So which means if you can find these functions, you can set a breakpoint at this function and then start debugging from there, so that you can you can debug the malware, so that you can set a breakpoint and start debugging at the start of the code. In case of Word document, auto open function and the document underscore open function gets automatically called whenever you open a Word document. So that is, whenever you open a Word document and click on enable macro, these functions will get executed first. and on closing the macro, these function would get executed. The same way, the Excel, if you're dealing with an Excel workbook, auto underscore open function or the workbook underscore open function gets executed first. So basically, these functions are a good place to set a breakpoint so that you can analyze the macro code, so that you can analyze the macro code from the start. This is similar to the address of entry point in the executable files, right? So when you open an executable files in a debugger, the debugger automatically breaks at the address of entry point. But in this case, we have to manually set a breakpoint. In order to manually set a breakpoint, we need to understand these functions so that we can set the breakpoint at the right place. Okay. So now in this. Now go back. Now let's analyze this macro and see what we can find. As you can see here, there is an auto open function here. So which means, and also this auto open function in turn calls auto underscore open, which is here. So I think this would be the right place to set the breakpoint, right? But the problem here is if I click on the run button, it says the macros are disabled. The reason is because we did not enable the macro. Now, if I go back to my document, you will see that there is no option to enable the macro here, which before it was there, but now it's not there. So, but there is a way to enable it. You can go to options, trust center settings, and then enable all macros, and click on OK. And click on OK again, and now go back to your Visual Basic editor, and if you run again, what will happen is it will still say that the macros are disabled. The reason is because the settings will take effect only after you reopen the document file, which means when I now open the document file, what happens is it should break here, right? But the problem here is once I reopen the document, all the breakpoints are removed, which means this code will get executed completely without breaking at this particular point. This is one of the problem. So how do we solve this problem? Okay. So one method that you can do to solve the problem is basically copy this code. Okay. And before that, let me go back and enable the macro options here. Trust center. I'm sorry, disable the macro options. This is the default setting. I'll keep it. I'll check the default setting. Okay. Yeah. So one method is copy this code. This is the malicious document here, Julian company request, and copy the malicious code. And now what I do is I open a new document, right? So let me close this. I open a new document file. This is not the original malicious document. This is a new document, and I press Alt F11. You see that it brings up a new document. It's blank now. I can now paste the code that I copied into this into the editor. Now I can set the breakpoint here, and now if I run, the breakpoint hits here. So now I'm able to stop at, I'm able to break at this point. Now I can start debugging the malware. But this approach has some limitations. I'll talk about those limitations in the next video. But for now, remember that this will not always work for some reason. I'll talk about the reason in the next video. But for now, it is okay. We can debug this malware. So let's try to understand what this malware does. You see that the malware here, it's calling a function, FGED something. So this is the function that it is calling. So you have two options. Now you can either step into the function or step over the function. Either you can go inside the function or you can execute the function and come out of it. Okay, so what I'll do is I'll go inside the function by pressing F8, and I'm here inside the function. Now let's see what the malware does. Okay, So you see that it is creating some shell, it is creating a shell object and storing it in a variable. Okay, and then it is using that object and calling this expand environment string to expand the environment variable and storing it in a variable here. As you can see, these variables are very cryptic. It is very hard to keep track of what's inside the variable. So one method by which you can keep track of what's inside the variable is, there are many methods of determining what's inside the variable. So one is either to print the content of the variable, or the other method that I find is useful is basically add to watch list. Let me run this and let me come here. Now I know that it is going to expand this environment variable and store it in this particular variable here. So after I run this, I should have this expanded string. So how do I watch this? Right click on this variable and click on add watch. That would bring up this variable. Now you see that the variable is empty because I've not run the code yet. You see that it's empty. Now what I'll do is I can again press F8, single step into, and now you see that that variable here contains the string which is C users administrator app data roaming. Right. So now we know that the malware expanded this environment variable and stored it in this particular variable. Now let's see what it does. Then it takes the expanded string and then concatenates with this particular string and stores it in a variable. Now you can add this variable also to the watch to see what to examine its content. So let's do that. So after I run this function, you see that it successfully concatenated the string here. You see here, it says now use C users administrator app data roaming and that particular string. Adding to the watch list is one method, but there is other method which I think is much better than adding to the watch list. Instead of adding each and every variable to the watch list, one thing that you can do is basically click on view local windows. This will show all the local variables of a function. Now I'm examining this function. Here it is showing all the variables as all the local variables associated with that function, right? So this would be much better to examine the variables. So far we know that the malware created a shell object and it expanded the environment string and it then concatenated that environment string with this particular string. Now it looks like it is creating a file object here, and then it is checking if this folder exists. The folder this variable, what is this is this particular variable here. It is trying to check if this particular folder exists inside the roaming directory. So let me go to that roaming directory and show you that by here the folder does not exist by default. Okay, so it is checking if this folder exists. If it exists, it doesn't do anything. If it, in this case, it does not exist, so what happens is it will go and create a file object and then create this particular, see this particular folder inside that directory. So let me run that. Now you see that, now if I go to the directory, you see that it created a folder here. Now we know that the malware actually created a folder in that roaming directory with this particular name. This can be used as an indicator to detect this infection. And also another thing is, then the malware actually creates an HTTP object, and it connects to this particular URL using the send request. So what you can do is you need not do a single step here by pressing F8. You can also set a breakpoint somewhere here like this, and then hit the run button, and it'll run till the breakpoint and then break. So now at this point, what should happen is it is going to connect to this particular URL. So what I'm going to do is I also have I have a Linux machine. All my traffic from my Windows machine will go through this Linux machine.
because the gateway for this Windows machine is set to the this IP address, that is 192.168.1.22, which is the IP address of my Linux machine, because of which all the traffic will go through this Linux machine. And also on the Linux machine, I'm running a tool called inetsim, which simulates all the services like the DNS, HTTP, IRC, and so on. The idea is that while debugging the malware, if malware is trying to resolve a domain, it will be redirected to this particular service, and this service will give a response saying that that particular domain is at this particular IP address. And then if a malware wants to make an HTTP connection, there is also an HTTP server running. So that way I can debug the malware without actually connecting the malware to the actual command and control server. Okay, so and also what I'll do is I'll also be running the packet capture here so that I can capture some of the packets while I am debugging the malware. Okay, so now the packet capture is on. Now let's go back to our code, and you see that after I click the F8, I'll click the F8 button. Let me set a breakpoint here and let me click a F8 button, and you see that after I click the F8 button, you see that there is a communication to that. On my Linux machine, there is a communication to the dl-drop-user-content.com, and there is a communication on port 443, right? So, and also you see on the Windows machine, it is giving me that the certificate is, do you want to accept the certificate? This is the certificate that is given by the inetsim tool, because it also runs an HTTPS service and it gives a fake certificate. You see that it is giving a certificate. I would say, let's say I say yes, proceed, it's okay, I accept the certificate, and let's see what happens now. Now you see it hit the breakpoint here. Now that I've accepted the certificate, it hit the breakpoint. Okay, so now let's see what the malware is trying to do. Now you see that the malware is reading the content from the command and control server. It actually requested let me show you that. It actually requested an executable file here. If you remember, it connected on port 443, and if you remember, it tried to download an executable file, and what it's trying to do now is it is trying to save the downloaded file into this directory here. This directory, the variable represents a directory here, which is C users administrator app data roaming, and then what it's doing, it's concatenating that with here. The AND operator is a concatenation operator. It's concatenating that with this particular string. So basically what it's doing is it is going to connect to this particular URL. It's going to download this executable and save it as this .com file in this directory here, that is C users administrator app data roaming RIXT BRXSCRN, inside this directory. So let me show you that before running the code, there is no executable with that particular name. But after I run this code, you will see that there is a file with that particular name that was created. And if you're thinking, how did the malware download a 24 KB file while we did not allow it to connect to the command and control server? So what happened was, when it requested for a file here, requested for this file, if you remember, it made an HTTPS connection, and because the HTTPS, there was an HTTPS listener that was set by the inetsim. Inetsim was monitoring for any communication. So when inetsim saw the connection to this particular URL, and it saw, when it saw that it is the malware trying to download an executable file, what it did was it gave a fake executable back. This executable, this 24 KB executable, is not a malicious executable, but it's a fake executable given by the inetsim. Okay, so we'll see that in some time. Okay, so let me go back to the code. So now we know that the malware downloads the, now we know the functionality of the malware. It's a downloader. it downloads the executable file from this particular URL and saves it on the disk with this particular name. Then what it does is it calls this function here, rr whatever, with a parameter, this one. Now if you remember, this parameter here is nothing but the name of the folder where it dropped the file, right? And it's calling the function. So what I'll do is I'll step into this function and see what happens here. Now I step into the function, you see the locals window is showing all the variables associated with that function. Okay, so now what it does is, let me set a breakpoint here, run. You see that it is creating a shell object, and then you see that it is creating a file system object here. Okay, then what it's doing is it is checking if this folder exists. What is this folder? Let's look at this variable here, YK. You see that it is trying to check if this folder exists here, and we know that this folder exists because it created previously. Just to show you, this folder actually exists. So what it does is, if it exists, then what it's going to do is it is going to get the folder, it's going to read all the files from that folder, and there is only one file in that folder, that is this file that it that is the file that it downloaded from the command and control server. And then what it does is it iterates to each and every file in the folder. In this case, there is only one file. Okay, for example, here it iterates through the first file, and you see that the first file is stored in this variable, and it is concatenating that with this particular variable, which is this particular variables, this one, it is concatenating this folder name with slash followed by the name of the executable, that is TPC in this case. In any case, we can look at this variable to see what it's concatenating with. You see that after a single step, you see that this variable would contain OGVD. Where is the variable? Yep. So you see that this variable contains this string here, which is the path to that executable that it downloaded. Okay, so it is trying to get that executable path, and then what it's doing is, once it got the executable path, it is trying to call run to run this the content inside this variable. The content in this variable is the executable file. So what it's going to do is, it's going to run this executable file that it downloaded. Now after I press F8, you will see that it ran that executable, and we know that this executable is a fake binary given by the inetsim, and it executed the binary. So now we know the functionality of this macro code. The functionality of the macro code is to download an executable file and save it to disk, and then execute that downloaded file. Now this is a macro downloader, right? So this is how you can debug the macro code. In the next video, we will look at another document, and I'll show you why this method has some limitations. When I say this method, if you remember, we copied the macro content from the actual malicious document and created a new document and then started debugging it. But this has a problem. We'll talk about that in the next video. So thank you for watching.